All right, example 2, page 16. Same type of question as the previous page. So you got to read this carefully. Profit on each set of cassettes that's manufactured by the Music Man Incorporated is $8. Profit on a single cassette is $2. Machines A and B are used to produce both types of cassettes. Each set of cassettes takes 9 minutes on machine A, 3 minutes on machine B. Each single cassette takes 1 minute on machine A and 1 minute on machine B. If machine A is run for 54 minutes and machine B is run for 42 minutes, determine the combination of cassettes that can be manufactured during the time period that most effectively generates the profit within the given constraints. So we could say X equals the number of sets of cassettes, and Y could stand for the number of single cassettes. And then what we could do is this. We can come up with our inequalities. So, or here, I can come up with a profit function here. The set of cassettes is $8 per cassette, per set, 8x. Single cassette is 2y. So here's our profit function. And then what it says is, if machine A is run for 54, or let's do it this way. Each set of cassettes takes 9 minutes on machine A, so that's 9x, and 3 minutes on machine B. So that's set of cassettes. So if I just stick with machine A, that's 9x, and then a single cassette takes 1 minute plus 1y, and machine A is run for 54 minutes, no more than that. So I could say less than or equal to 54. And then if I go to machine B, the set of cassettes take 3 minutes, so that's 3x, and the single cassette takes 1 minute on machine B. And we have 42 minutes run on machine B, so it's got to be less than or equal to 42. And then what we could do is then graph this. So I could find the intercepts here to help me come up with my scale. So I'm going to choose to go by a number that's divisible by all of these. Or let me just do it this way. On the x-axis, these are pretty small. I'll go by 2s. And the y-axis at 42, 54, I'll go by 6s. So first one, 6, 0, and 0, 54. And it's less than or equal to that, so we shade this way. Second one, I have 14, 0, and then 0, 42. And it's less than or equal to that. So it's common to both of these. So what's common to both of these would be this region here. Because if I shade in here, what's common to both the shading is this region in here. And another constraint that we could say is X and Y, the number of sets of cassettes and single cassettes have to be positive. Because if not, we keep on shading. So now these vertices here would be 0, 0, 0, 42. This is 6, 0. And if we can't tell this one, it's where these two lines intersect. So we could actually just solve this system. And I'm going to solve this system by just subtraction. If I subtract, these will cross out, and I get x is 2. And if I plug that into either one, I could find y. And I get y is 36. So I have my 4 ordered pairs. I'm going to plug all of these in. 0, 0, 6, 0, 0, 42, and 2, 36. And if I plug them into here, we want the maximum profit. So 0, 0 will give me 0. 6, 0 gives me 48. 0.42 gives me 84. And that's it. These are all dollars. 2.40, 2.36 gives me $88. So what's the combination that will maximize profit? It would be 2 sets of cassettes. And then 36 single cassettes. That would be example 2. Example 3 on the bottom of page 16. The Whittle Carpentry Shop makes bookcases and cabinets. Each bookcase requires 15 hours of woodworking and 9 hours of finishing. Cabinets require 10 hours of woodworking, 4.5 hours of finishing. Profit is $60 on each bookcase and $40 on each cabinet. There are 70 hours available each week for woodworking, 36 hours available for finishing. How many of each item should be produced to maximize the profit? So X could stand for the number of, or the amount of bookcases produced. And Y could be the amount of cabinets produced. So our profit function is $60 per bookcase. That's 60 times X, and $40 on each cabinet, 40 times Y. And now we need our inequalities. So each bookcase requires 15 hours of woodworking. So if we just go to woodworking, that's 15X. The cabinets require 10 hours of woodworking, that's 10Y. And in total, we have 70 hours available, less than or equal to 70. The other inequality would be this. Each bookcase requires 9 hours of finishing. So that's 9X. The cabinets require 4.5 hours of finishing. That's 4.5Y. And in total, we have 36 hours available for finishing, is less than or equal to 36. For each of these, we want to find the intercepts. It'll help us to graph. So we're going to set X equal to 0 and solve for Y. That is 7. If Y is 0 and solve for X, that would be 70 over 15 or 4.6 repeating. We do the same thing here. If X is 0 and you solve for Y, you get 8. If Y is 0 and solve for X, you get 4. Because the numbers are small, I'm going to go by ones. And the other thing we could say is the number of bookcases and cabinets cannot be negative. So you can always say that. Because if not, the graph would just keep on going down further, and it should be a polygonal convex set. So if I just graph the intercepts, 0, 7, 4.6 repeating and 0, and it's less than, so it's under here. And then the next one is 0, 8. I'll use a different color. And 4, 0. And it's less, so it's below here. Now, 4 of these vertices will be easy to figure out. The other will have to do some work. 0, 0, 0, 7, 4, 0. And these lines intersect. So I could actually solve this system if I can't tell. So if I solve this system, what I'm going to do is this. I'm going to multiply the top by 3 and the bottom by -5 to get the x's to cancel. If you graph this very accurate, you can maybe avoid this, but that's how I'm going to do this. If we carefully solve this, we're going to get y to be 4. And then if we plug into either equation, we could solve for x. And when we do that, we get x equals 2. So when we plug in these values into this function, those are the only ones we would consider. So I'm going to plug in 0, 0. I'll just do this down here. 0, 0, 0, 7, 4, 0, and 2, 4. So if I plug in 0, 0, I get 0, 0, 7. I get 280. 4, 0. I get 240. And then 2, 4. I also get 160 plus 120 is 280. So there's two scenarios here. If you want to maximize the profit, you can go with 0 bookcases and 7 cabinets, or you can have 2 bookcases and 4 cabinets to maximize the profit. So that would be examples 2 and 3 from page 16 from chapter 2.